During this pandemic, one thing that has become very important is reducing the spread of the virus. You may have noticed at some stores and restaurants, there's a cup of clean pens and a cup of dirty pens. This is a makeshift solution to reduce common touch points that are pens between customers. Unfortunately, this solution doesn't solve all our problems. It requires lots of pens, and there's no good way to clean the dirty pens. We've worked with GE Healthcare to create an innovative solution to this interesting problem of pen sanitation.
We began our project by having each team member sketch 10 designs to be evaluated later on. We then researched background materials individually and shared our findings with the team during our virtual meetings through Blackboard Collaborate. As the project went on, we started creating computer-aided designs using SolidWorks. Finally, a detailed timeline was made to make sure that we can finish our project on time.
Upon receiving our project, we met with our mentor/client for this project, Scott Schulz, who has been working for almost 3 years at GE Healthcare as a verification engineer. He was able to give us realistic prices for our product, advise us to take ADA guidelines into account, and created new ways of looking at our challenge and what potential product we could create. With his advice, we created a list of specifications that include the following.
We started out by brainstorming 3 main design ideas: the self-cleaning pen design, the barrier design, and the pen dispensing design. We listed pros and cons of all these designs by using an online discussion app called Mural. Then we quantified our evaluations by listing numeric scores under 6 important categories. After adding all these scores up, the one that came out on top was our pen dispensing design, and this was the design we decided to move forward with.
For the body of our device, we decided to use black acrylic plastic and laser cut out each side. We attached them using a finger joint notch mechanism and glue. We 3D printed our dispensing wheel out of Ultimaker PC for its strength and toughness. For our disinfectant, we chose to use an ethyl alcohol hand sanitizer since it's able to neutralize COVID-19. When designing the cleaning system, we also decided to buy a small pump to use to spray the pens, as well as an Arduino controller to operate the system. With help from Nathan Strachan and the Team Lab staff, we were able to successfully design and create a circuit to power the pump using the Arduino.
We were able to complete testing for 3 components of our device. The first component was our assembled body. We found that sanding the finger joints and using super glue to adhere the faces together adequately held the body together. We did some rough torque tests, and this fabrication method withstood any amount of torque we could naturally put on the device. We were also able to test the Arduino circuit that powered the pump. We found that our power supply and electronics were adequate to power the pump as necessary. Finally, we were able to print the cylindrical dispensing method and ran rough tests to make sure that it would properly store a pen.
Our final design is a 25 by 23 by 18 centimeter box constructed out of black acrylic. There's a slot in the top where the pen will be inserted. It will then roll underneath the sanitization spray and be completely sanitized. Then the pen will roll into the gate wheel where it will be kept and dried until it is needed. Our fabrication was all completed except for the construction of a tank to hold the sanitization spray and then attaching the pump to it. The testing was additionally almost completed except for testing the pump and vinyl tubing in the actual box that we had constructed. Our design solves the problem of spreading diseases between cashiers and customers at restaurants and shops by eliminating the shared surface of the pen. Our design completely cleans the pen, is very efficient, and also can clean multiple pens at once, thus completely solving the issue.